So for chapter 4, question 5, in figure 4.7, two blocks are connected by a string, as shown. And the upper block is pulled upward by a different string. The masses of the upper and lower blocks are 300 grams and 240 grams respectively. The string between the blocks will break if the tension exceeds 3.6 newtons, and the string which pulls the combination upward will break if its tension exceeds 7.8 newtons. They're asking, what is the largest upward acceleration that the block can be given without either string breaking? Take G equals 9.8 meters squared, and B is asking if the upward acceleration is slightly higher than this, which string breaks? The net force on the system is expressed by the equation T1 minus parentheses M1 plus M2 parentheses Y equals M1 plus M2A. We then go ahead and use this formula and plug in our values. We get 7.8 newtons, parentheses 300, parentheses 1K over 1,000 grams, plus 240 grams, parentheses 1 kilogram over 1,000 grams, parentheses 9.8 meters per second equals 300 grams, parentheses 1 kilogram. We then go ahead and solve all this, and we get 7.8 newtons minus 4.292 newtons equals parentheses 0.540 kilograms, parentheses A. We then simplify this further and get that A equals 4.64 meters per second. So the acceleration is 4.64 meters squared. Now, B's asking the net force on the bottom of the block. So for this, we're going to use the formula T2 minus M2G equals M2A. We go ahead and get our values and plug them in, and once we do that, we go ahead and solve and get that A is equal to 5.2 meters squared. So lastly, the last thing that we need to find is the acceleration. At this acceleration, the tension. So we use the formula T1 minus M1 plus M2 G equals M1 plus M2A. We go ahead and use this formula and plug in all our values, and once we do all that, we go ahead and get 8.1 newtons.